Hello once again, Year 10. I thought it would be useful for me to go through similar styles of problems to those that you'll be meeting in some of the MathsWatch tasks this week. The new topic we're meeting is direct and inverse proportion. Now this is a topic that you will have studied in science, you just may not have heard it referred to in quite the same ways as I'm going to. But for example, in Year 9 in physics, you should have learned that the pressure of a gas is inversely proportional to its volume, i.e. P is equal to K over V. Or more likely, you will have learned that as PV is equal to a constant. But they're both the same statements. Equally, also in Year 9 physics, you probably will have covered the idea that kinetic energy is directly proportional to the square of velocity. And it's really those ideas that we're going to be grappling with today. So the first question I want to look at states that y is directly proportional to x. The first thing I do in any of these questions is I'm just going to write down my information. I use alpha to denote directly proportional to. So y is directly proportional to x. If y is 5 when x is 25, find an equation for y in terms of x. So if y is directly proportional to x, what I'm saying is that when I double x, I will also double y. And that means that y is equal to some constant k that I don't know, multiplied by x, such that if I multiply x by 2, I'll get 2kx, which multiplies y by 2. I can work out k using this information. If y is 5 when x is 25, then I get 5 is equal to 25 times k, and so k is equal to 1/5. And that gives me my equation, y is equal to 1/5 x. Part B asks me to use this equation to find y when x is 100. So I just sub in x is 100, y is equal to 1/5 times x, which is 100, so y is equal to 20. And that's a nice straightforward question. Write down your proportionality, write an equation using a constant of proportionality, I always call them k for simplicity, sub in the known values to find k, and then write out your equation again. And then when using that, just substitute in as you would to evaluate any formula. Second question is very similar. Y is directly proportional to 1 over x, so that means y is inversely proportional to x. In other words, if I double x, I halve y. If I triple x, I multiply y by 1/3. And x is 4 when y is 5. Part A, find the value of x when y is equal to 10. Now that's just asking part A and B of the previous question all in one. The first thing I need to do is write my equation. I know y is directly proportional to 1 over x, so y is equal to k over x. I substitute in my known values to find k, so I have 5 is equal to k over 4. Multiply both sides by 4, k is equal to 20, and so y is equal to 20 over x. And I want to find the value of x when y is 10. So I sub that in, 10 is equal to 20 over x, multiply both sides by x, 10x equals 20, divide both sides by 10, x is equal to 2. And so that all seems fairly straightforward. And indeed, I did say if I doubled x, then I would halve y. That's what this proportionality means. So equally, if I halve x, then I must be doubling y. So 4 halves to 2 and 5 doubles to 10. So it seems to make sense. Part B, sketch the graph of this proportion for positive x, marking 2 points on the graph. So you've got some coordinates here, which is very helpful. You know that when x is 4, y is 5. You also know that when x is 2, y is 10. So they're the 2 points you're going to mark on your graph. So I'm going to just draw a quick sketch here. So I have 4, 5 roughly here, let's say, and I have 2, 10 roughly here. And I know that y equals some constant over x. That's a reciprocal graph. So I know what that looks like. It's asymptotic to the y-axis, it's asymptotic to the x-axis. That is, it approaches but never touches either of those values. Now it says for positive x, that's all I need to do. If I were sketching the whole thing for negative x as well, I would have a reflection in the line y equals x of this line, once again asymptotic to my axes. But here we just have a simple positive reciprocal graph, and we've plotted our 2 points as required. Question 17 gets a bit of physics in there, which of course is always pleasing to see. The gravitational pull of the Earth is inversely proportional to the square of the distance from the centre of the Earth. That's absolutely true. At the Earth's surface, approximately 6,371 kilometres from its centre, the gravitational pull is around 9.8 newtons per kilogram. When launching a satellite into space, the gravitational pull helps determine the orbit. What would be the gravitational pull on a satellite at a height 100 kilometres above the Earth's surface to 1 dp? Now, there's lots at work here. Firstly, I'm going to summarise this. The gravitational pull of the Earth, that's a force, so I'm just going to call it F, is inversely proportional to the square of the distance, and I'm going to call that r squared. Just that's radius out from the centre of my planet. So F is directly proportional to 1 over r squared. We're actually getting quite close to Newton's law of gravity here, but that's beside the point. And therefore, I know F is equal to k over r squared. At the Earth's surface, 6,371 kilometres from the centre, so r would be 6,371, the gravitational pull is around 9.8 newtons per kilograms. Now I see they're using gravitational pull, so I should really call this G, as in gravitational field strength. I think that's quite a badly worded question as a physicist, but there you go. So G is equal to k over r squared. Also true. And I'm told that so when r is equal to 6,371, G is equal to 9.8. So I have 9.8 is equal to k over 6,371 squared. So k is equal to 9.8 times 6,371 squared, which is equal to 9.8 times 6,371 squared. Let's just go in standard form. 397.8 times 10 to the 6 for my constant of proportionality. In other words, G is equal to 397.8 times 10 to the 6 divided by r squared. That's what we found there. And then I'm asked to find the gravitational pull on a satellite at a height 100 kilometres above Earth's surface. So if I think about this, what I'm saying is I have Earth of radius 6,371 kilometres, and then my satellite is another 100 kilometres above the surface of the Earth. So in total, the value I'm trying to find is when r is equal to 6,371, centre of the Earth to the surface, plus 100, 6,471 kilometres. So G then is equal to 397.8 times 10 to the 6, divided by 6,471 all squared. I'm going to use the answer button on my calculator. So answer divided by 6,471 squared is equal to 9.50. Oh, in fact, ask for 1 dp, 9.5 newtons per kilogram. And that makes sense. I'm not that much further away from the surface of the Earth, and therefore I would expect to be slightly below the gravitational field strength, but not massively. And that's about as hard as these questions can get at this level. As always, if you need any more help, please do ask your teachers or myself, either via email or the Google Classroom. And good luck in your end of year exams in a couple of weeks' time.